Hello and welcome to this lecture, part of the course Introduction to Apache Spark. We will see how you can run Spark using CERN computing resources. I am Luca Canali with CERN IT Data Analytics and Spark Service. First, you can start small. You can start developing on Spark using your laptop, desktop, or VM resources, and there are many ways you can install and run Spark in such environments. For example, you can pip install PySpark, or you can download Spark from the Spark website, or you can run Spark as a Docker container with Docker run, as listed here in the slide, both for Python and for the Spark shell. Then you can move on and run Spark on clusters at CERN. Currently at CERN we have clusters where you can run Spark on Hadoop. So Yarn is the cluster manager, Hadoop is the platform. And then you can run Spark on cloud resources using Kubernetes. For example, in production we have a system for the NSCALs project. This is only available for the members of this project. And then we have another larger cluster for general purpose usage. It's an Hadoop cluster currently of 58 nodes. 20 petabytes of storage, almost 3,000 cores, and about 30 terabytes of memory. And then we have a small deployment using cloud containers, where Kubernetes runs on the CERN OpenStack private cloud with a smaller amount of resources, but this is scalable and it may scale up in the future. And this allows you also to use various storage systems. You can remotely access HDFS, or you can also remotely access CERN EOS storage or S3. And in these systems also GPUs are available. How you can get started using the Spark services? The documentation is at this link, Hadoop user guide as in the slide. And if you want also to use Spark with Hadoop clusters, you need to request access to Hadoop clusters using CERN ServiceNow. So in terms of clients, so how can you access the Spark and Hadoop resources from your client system? So one possibility is the Swan service. We will come back to that. This is a hosted Jupyter Notebook service, and this is the URL. Or from the command line, you can SSH to ad hoc edge nodes that are configured with all the Hadoop configurations and Spark software. And for this, you just need to SSH to the IT Hadoop client machines. You will find a managed Spark environment. We will get later on how you can start the configuration and then start up Spark as you need. Then we also have container images customized for the CERN Hadoop usage. You'll find the details on how to run them in the Hadoop user guide. And also you can run using LX+. So if you're using the IT Hadoop client, which is recommended for the command line, while for notebooks it's recommended to use one, this is what you need to do. You SSH to IT Hadoop client. You will get to one of the machines load balanced under this alias. Then you will need to source the configuration. This will set up for you the environment variables and the configuration files that you need. Typically, you will want to use the general purpose cluster analytics on Spark 3. And you just copy paste here. And then let's say you want to run PySpark, so it's the Spark shell. For Python, you just need to run PySpark. There are more configurations that you can run there. This will get you started. It's also possible to run a Spark application in multiple ways. So the shell way with PySpark that we just seen in the previous slide, and the equivalent shell for Scala, which is called a Spark shell. Or you can use self-contained applications. You can have applications in Python or Scala or Java, and those will use Spark as a library. And you can also use Spark Submit to submit jobs to, let's say, Hadoop or Kubernetes to run in batch mode. Let's go through the various possibilities. So the Spark REPL or shell will allow you for interactivity, where you can develop and debug real time. Spark has a Python shell, the PySpark, Scala shell, Spark shell. And in those environments, you get the Spark session already available, and it's called Spark. Simple to get you started. You can use Spark as a library, so this moves you more into a program-like environment. Let's say you're writing a Python program that needs to access Spark. You will need to have PySpark installed. So let's say pip install PySpark. And then from there you can have this import. Let's say you import the Spark session. Typically you will import also other parts of PySpark, but just to create the Spark session you need that. And Spark will be the Spark session, and you build it with an application name. You specify what type of resources you want. This is using local, so let's say your laptop, and if you need to connect to Hadoop, that would be Yarn, or Kubernetes, it would be Kubernetes. And then this will create the Spark session. And then you can just run a simple command to see that this works. Let's say you put this into a file. Let's call it my_code.py. And then you can run it with Python. And this will run a Spark program. And this will run locally. With minor modifications, this can be used to run also on a cluster. Spark submit. This is the way you use to submit batch, let's say programs to a cluster manager. So batch, ETL use cases and similar. Let's say you have Spark installed, and then under the bin directory you have Spark submit. This time we assume we have all the configurations to connect to an Hadoop cluster. So we can specify master yarn, which means the Hadoop resource manager. And then there are several configurations we can specify. Let's say we want to have 2 executors, each with 8 gigabytes of memory. And then we want to run a Python program. This is a famous example that computes digits of pi using a Monte Carlo method and using most notably the Spark APIs. And we can run this will run on the cluster and gives us the result. So then you need to know more about the configuration if you want to be proficient on the usage of clusters. So the first thing I would like you to point to is the configuration files. So there are at least 3 main configuration files you need to be aware of. They are located under Spark home/conf, or if you set it, the Spark_conf_dir. The first one is called Spark defaults.conf, and it contains the application parameters, so all the Spark properties. We've seen some in the command line before, so we can store these properties, for example, number of executors, the amount of memory per executor, and other configurations can be stored there. Then there is another file that you may want to edit. It's not always the case. It contains the per machine settings. And another file you need to be aware of is the file that configures the logging. Recent versions of Spark use log4j2, and this is the log4j2.properties file. Previous versions used log4j version 1.x, and the properties file is as you see in the slide. Okay, when you are using Spark more in a programming way, we can get the configuration at the time when we create the Spark session. Let's say again in our example of creating a Spark session with Spark Session Builder, we can have 1 or more configurations. Let's say Spark executor course 2, and then we can have more configurations. This can be specified here, or they can be set in the configuration file that we've seen before. I'm going back one slide, Spark defaults.conf. Going back to the current slide. So this is how you set the configuration in a programmatic way. Spark properties can also be specified at the runtime as command line options. This is typically done with Spark submit, or for example, if we are using PySpark, we can specify --master yarn, --app name, --conf, and all the configurations that we want to set. Spark properties, as mentioned earlier on, can be set in a spark default.conf file. You can see there is a configuration file already that comes with the Spark package, where you can see some examples. It's simply configuration name and then value. Logging is, as mentioned, with the file log4j2.properties. You may want to set some components of Spark with a higher or lower logging level to have more logs, for example, when you're debugging. And then we mentioned also the spark.m-.sh file, where you can set environment variables. Okay, when you're running on CERN resources, everything is already packaged for you. Let's say you connect to the IT Hadoop client machines or other machines where you have the configuration set up for CERN. There you just need to run source hadoop setconf.sh, name of the cluster, then the fact that we run with the latest Hadoop and the latest Spark. The configuration of the CERN Hadoop machines also has additional parts, in particular for Hadoop. There is an Hadoop confdir directory that points to the various Hadoop configurations, notably pointing to the Hadoop cluster that we want to use, and also other parameters. Okay, now I want you to see how you can set dependencies for Java. Let's say you need to add some custom jar files to extend the functionality of Spark. And then this can be done simply with the ---- jars configuration option, and then the list of jar files. The jars will be copied to all the executors and added to their class path. Sometimes what you need are just jars that you take from Maven Central, for example, to add some functionality, some logging to Spark. And this is done with ---- packages. This will go to Maven Central, where the packages will be fetched, and also dependencies will be fetched, put in a local cache, and then the same as with ---- jars, the jars will be copied to executors and added to their class path. Similarly, for Python, you can distribute Python files or zip bundles to the executors using the command line option --py files. When you're using Swan, there are also additional handy configurations to propagate packages that you installed with pip install --user. There are more advanced use cases on how to manage packages with Python and Spark. I refer you to the Spark documentation. CERN Swan is an analytics and machine learning platform. It's a hosted web notebooks that is integrated with many different systems of interest at CERN. So the UI is with Jupyter notebooks and also a Jupyter lab coming soon. And then it's integrated with many different types of software, all the CDMFS software of interest for CERN. This also contains packages of interest for data analysis. It could be TensorFlow, PyTorch, or several Python packages like Pandas, then of course Root. And then it's integrated with Compute, Apache Spark clusters, then Hadoop clusters, HT-Condor, and CDMFS, CERNBox, EOS, and then it runs on VM and the OpenStack system. When using Spark on Swan, the configuration is simplified because you have a web UI that you can use to set all the configuration parameters. An example here, Spark executor memory that is already selected, and the Spark executor course that is being entered while I took the snapshot of this configuration page. And there are also bundles that you can use with several configuration parameters already pre-configured for certain functions. Swan has also access to GPUs, which are useful, for example, for the use cases of machine learning, If you need to run TensorFlow or PyTorch, you can do that on GPUs. As mentioned in the lecture on machine learning with Spark, sometimes you want to process the data scale with Spark, save it in a format that then can be used to read it back again into TensorFlow or PyTorch for example, training of the models using GPUs. This brings us to the key learning points for this module. So you can run Apache Spark at scale on CERN resources using Hadoop clusters and cloud resources with Kubernetes. Spark has a large set of configuration options. Moreover, you can use Spark in multiple modes. You can use it from the shell, Python or Scala, as a library, as batch, indeed languages Python, Scala, and Java. CERN's Swan web notebook service is integrated with Spark and Hadoop clusters. So it's a good way to reduce the complexity of running Spark, and definitely an option we recommend when you want to start exploring Spark at CERN. I invite you now to go to the notebooks that come with this lecture and the associated videos.